Here at work, we have an example of a privacy screen. As you can see, now the light's not on there, but as you can see, you can kind of peek in, and we'll do that in a moment, and you can see what's going on. And on the outside, it's just a normal screen. If we come in from the other room, this is kind of a room where we end up having a lot of important information. And you can see from this room, almost like a two-way, it's just a piece of glass, really. Kind of reminds me a little bit of those precincts where it's a privacy one-way glass. But that's not quite what this is. This is a really cool technology where when you feed electricity through it, and there's a wall switch right here, you can't see anything. Isn't that neat? Throw a little electricity on, and those crystals align, and light goes right through for the most part, as you can see. Throw it off with no electricity and you can't see anything. Now I'll put the camera as close as I can to the glass, so maybe be a better example. And then as soon as we turn off the electricity, as you can see, only the very light stuff, maybe on a sunny day you can see a shadow or two. So how does this work? Well, one of the most important aspects that people might want this is obviously for privacy, right? Normally you want light coming in, you want your rooms to be shiny, saves a lot of electricity, it's a more opening environment, but every once in a while, if you're discussing, something private, and it could be anything, and maybe you don't want someone walking, or maybe this is an office, and you don't want someone stopping in and kind of going, hey, what are you doing, man? What are you doing? And that can be annoying. Even with drapes, you see the shadows. So you do something like this, and you're really assured that anyone who's walking by can't see. And as an example, we can take a look at what they're going to see on this side. As you can see, it's just as opaque as ever. So it's pretty neat on how that works. So I wanted to discuss real quickly of kind of how this works. Not the theory so much, but okay, it's a little bit of the theory. But there won't be any math, I promise. So how a privacy glass like this is made is you have one piece of glass on the outside and another piece of glass on the other side. There we go. So these are just two pieces of glass. That's this guys. Now in between that glass you have a film. So this is a film and this is a film. Okay, kind of like a polycarbonate type of film. LCDs have these a lot. Then after you have the film, the way that these works is you have now an electric bus bar, basically a very thin electrically conductive wire. And let's see if we can make that a little darker. Isn't that cute? So that's one bar here and one bar here. This is obviously the expanded form. So again, this is we can make this the glass. You have a film here. Let's not do that. That'll complicate things. Okay. And you have the film here, a piece of plastic, and then you have the two conductive bars. Now, what's in between here? Well, this is called, it's the liquid crystals. And so you have tiny little liquid crystals that when the power is on, okay, when the power is on, so you have a, plus and a minus here. I don't know what the voltage is. Let's just assume it's 20 volt. It could be higher or lower. It depends on the transformer. But when you're feeding 20 volts into this guy right here, all of these liquid crystals are aligned. And because they're aligned, what that means is when you are looking through the glass, right, you have light that's coming in, okay, hits the piece of glass, goes right through that plastic layer, goes through the charging layer, all the way here and outside the glass. So you have basically light coming in straight for the most part. Not an issue. This is when there is charge applied and these liquid crystals align, right, perpendicular to the charging plate where they're all parallel at each other. And so that state is here. This is that state here. They are now all aligned parallel to each other. In this case, they'd be going out this way. Right, they're all aligned so we can see right through. So what happens when we shut off the power? In other words, we're not exciting these molecules and these liquid crystals. Now, what happens to this? Well, that's kind of a law of thermodynamics, right? anything that's going to disorganize to lower energy state, it is. In this case, we have lower energy state because we're not inducing a charge. So what happens, these liquid crystals, now, I'm going to remove this light, all of a sudden, instead of being parallel to each other, now what's actually happening is, with no current being applied, they're kind of like this. They're all over the place, right? A little bit here, maybe another one here. So what this means for light, well, you have light trying to come in, right? Same as before. Goes through the glass, no problem. Through that plastic layer, not an issue. Through the charging plate, and then all of a sudden, what happens? Well, now you have light here, and it's going here, it's going in this direction, it's being reflected back off here, and then finally out here. So light is now being dissipated all over the place, right? It's being redirected all over the place, come back here, and then maybe now it goes out. So this is the state. You can kind of see from here that this glass currently is in with no voltage on the bus rail on the left side and the right-hand side. These liquid crystals are disorganized, right? And as a result of that, you end up with an opaque window, opaque/translucent, because you can see a teeny bit if you get close. Anyway, I've always been fascinated by these windows. I think they're pretty cool. So that's you know, in essence how it works. It's just so cool, right? I need one of these for my shower, for my house.